Okay, we might make a start. So welcome to week 4 of Programming Fundamentals. And so we'll start now. And so here's a bit of a roadmap of where we've been and where we're going. I'll just do a sound check first. Can everybody hear me? Maybe you can respond by talking or respond in the chat window. Can hear, thank you. Yep, Klein, thank you. Callum, Paul, thank you guys. Thank you, that's great. Okay, I'll put the chat window over there. Unfortunately, the chat window is not recorded, which is a bit of a shame. I think it's for privacy reasons, but so we can see where we've been. And so this week we're doing looping. Next week we're doing some really important stuff. This is core for the course, and it's all on creating objects, creating our own classes, creating methods within those classes. Okay, so we'll be creating our own objects and methods and things like customer class, and that might have methods like create a customer, check their credit rating, all that sort of stuff. So then we'll be moving on to arrays, 2 weeks of arrays. Now these are only short lectures. These are only about 30 pages each. And then we've got an introduction to swing components, which is our GUI programming week. We've got 1 week of GUI programming. So what I might do, I'll put it out to the class anyway to see if you want to do this. These will only be very short lectures. They'll be within less than 45 minutes. They're only very short weeks. We could combine those 2 weeks if you wanted, and then have an extra week of GUI programming, if you wanted to do that. It's up to you. If you want to do it, we can do it. I'm happy to do it. And then week 10's characters, strings, and the string builder class. And then week 11's some other really important stuff, which is file input and output. So we can load data from files and save data to files. So that's sort of where we're heading. But so that's our future. And like I say, there's the ability there to combine those 2 weeks into week 7, and then have 2 weeks of GUI programming if you want to. So let me know. Let me know on the course forums or on email or whatever you want to do, or on the chat window if you want to do 2 weeks of GUI programming. Okay, so yep, Wayne likes it. Jared likes it. Beautiful. Okay, I'm pretty sure Sanjan liked it too. He was talking about it last week. So and GUI programs where you get to write nice little applications too. So I mean, like not the console apps, which are sort of 80s technology or 70s technology, really. Okay, so last week we looked at A Brave New World, and we looked at we had our first Zoom class, which didn't go well. This one's gone a lot better. Last week's one, the first half hour, was dropping in and out like crazy, so it was very frustrating for me, and it would have been for you as well. And we worked through week 3's PowerPoints, which was on making decisions, if statements, else statements, else if, and the good old switch statement. So we looked at those there. And we also looked at a compact conditional statement, which I'll look at again in a second. And this week it's all on week 4, and we're going to look at looping. Okay, so how to loop through and repeat a block of code or whatever as many times as you like. So a quick review of last week. From last week we looked at the conditional operator. Here's a little example you can use to understand them a bit better. So int x equals 15, whatever x might be. Int a equals 0, just defining 2 integers, setting them equal to some sort of value. If x is equal to 15, a is equal to 2, else a is equal to 5. So it's just some if statement. I don't know what it means. It's just making up numbers. There's no actual meaning for it. It's just an example. Okay, so if x equals 15, set a to 2. Otherwise, set a to 5. Okay, and we can actually achieve that in one line of code using a conditional operator. So x equal to 15, so that's that part there. X equal to 15, question mark. And then you put what happens if x is equal to 15, that's the true part, and that's the false part. So you can actually achieve what this does in, say, 4 lines of code, or you could write it in 2 lines of code or even 1 line of code, but you can achieve it more compactly with that. So you can actually write this like this if you wanted to. If lines of code was really important to you, and You could write it like that. And that would be almost as compact. And or else you can even write all on one line of code, because Java doesn't care about white space. It's just humans that make it more understandable. So really, when you look at it, it's not much thought than that. So you're happy to have that code. Maybe you're happy to have that code as well. Anyway, so conditional operators there. Some people love them. Some people use them like crazy. Some people abuse them, overuse them when they're for things there, in ways they're not really meant to be used. But they're there if you want them. Okay, on to loops. So we'll learn about the loop structure. We'll create while loops. We'll use the arithmetic operators. We talked a little bit about those in the tutes. We use the for loop, which we covered a little bit in the tute, but we'll cover it all today, so don't worry if you missed the tute. We'll look at the do while loops, nested loops, and we'll look at ways you can improve loop performance. And there's some interesting hacks that you can use to slightly speed up your loops. So the loop is a structure that allows repeated execution of a block of statements. The loop body is a block of statements and is executed repeatedly. So each loop's got a loop body, and that loop body is repeated many times. So it's just a block of code that gets repeated as many times as you like, or until a certain condition is met, or until a certain bunch of conditions are met. So it all depends on what you want to do and how you want to do it. And an iteration is one execution of the loop. So one iteration, and it could be many iterations. It could be infinite iterations if you left a loop running forever. There's three types of loops. There's a while loop, and the loop controlling the Boolean expression is the first statement, and you evaluate that at the start of the loop. There's the for loop, which is a concise version of the loop. They're also called counter control loops, for loops, and a do while loop. And the loop controlling Boolean variable or expression is the last statement to be evaluated or executed. Okay, so there's everything you can do with the while loop, you can do with a for loop or a do while loop. Everything you do with a do while loop, you can do with a for loop or a while loop. They're all completely interchangeable. There's just three varieties of the same sort of structure to give you flexibility about laying out your code and how you want to do things. Okay. So you don't have to learn all three if you don't want to. You can just do everything with a for loop or everything with a while loop. They're all completely interchangeable. So here's the sort of thing we're going to be doing. So there's some sort of expression is going to be evaluated. And if that's false, we're going to exit the loop and continue execution after the loop. Otherwise, if it's true, if the Boolean expression is true, we're going to run the loop body and then come back and check the execution of the Boolean expression again. Is it still true? Run the loop body. Okay, so the main difference between the while loop and the do while loop is that when this is evaluated. In this example, this is evaluated first, and then the loop body is run. So that's the equivalent of a while loop. If we move the loop body up to here, into this gap up here between the arrows, so it was run, and then the Boolean expression was evaluated to see if a loop happened again, that would be a do while loop. So we'll start with while loops. The while loop executes a body of statements conditionally. As long as the Boolean expression that controls entry into the loop continues to be true, as long as that is true, the loop will continue to iterate or loop. Okay. So it consists of a while loop followed by a Boolean expression inside round parentheses, followed by the body of a loop. It can be a single statement or it can be a block of statements surrounded by curly braces. Okay, so you can have a single statement inside a while loop. You can actually have no statements within a while loop as well, or else you can have a bunch of statements within curly braces. So a loop's, if you've got a definite loop, it performs a task a predetermined number of times. For example, you know you want to loop until it's Tuesday or until midnight comes, or you want to loop 50 times. So you want to loop a definite number of times. that's also sort of like a counter control loop. So you want to loop a definite number of times. So when you want to do a loop like that, you initialize the loop control variable, the variable whose value determines whether the loop execution continues. And then while the loop control variable does not pass a limiting or threshold value, the program continues to execute the body of the while loop. So a definite loop, a counter-controlled loop. You know how many times you want to loop, or how many times you want to iterate. So here it is in flowchart form. So LCV is just the loop control variable. You set up some integer, you set LCV equal to 1. Is LCV less than the limit? If it is, then we do whatever we want to do in the body of the loop. In this case, it's just outputting the value of the LCV to the screen, adding 1 onto the LCV, and then going back again, coming back down. Is LCV still less than the limit? Yes. We output the LCV, add 1 onto it, and keep going until we finally get to the limit. Okay, and then eventually we'll hit a limit, whatever that limit is. It might be 1,000, it might be 100, it might be 10, it might be 5, and eventually we'll be not less than a limit anymore. So the loop will exit, and whatever's down below the loop will be executed. Whatever statements are down below the loop code. In Java, this would look like this: int LCV equal, or whatever, final int limit equals 11. So it's a constant, that's why it's uppercase. It's got the final there. LCV is equal to 1, while LCV is less than limit. Print line to the screen, and then add 1 onto it. That's the end of the body of the loop, because that was the start of it. So we go back up again. Is LCV still less than the limit? Yes, we'll print out LCV and add 1 onto it, and keep looping until we're no longer less than 11. Okay, so that's an example of a for loop. Are there any questions on that? Is anyone confused so far? Everyone okay? Okay, so could you have an else? No, there's no else, so it's not while else. If the else only belongs with an if. So it's like while or always. So while whatever conditions are true, you execute the body of the loop. Whatever that might be, there might be many statements. And then afterwards, when the loop finally exits, that's when you come down here and run this code. Okay, so you run it after the loop finally exits. Okay. If you wanted an else to, so I'm just reading the comment here. So it just runs whatever it is after you. You don't need an else. No, you don't need an else. You can't have an else. Else just goes with if. Okay. So write a definite loop. The loop of the body loop must include a statement that alters the loop control variable. If you've got a counter controlled loop here, int LCV is equal to 1. LCV is less than limit, and we've already defined limit up above somewhere, and we've got system.out.println LCV. So if that was the body of our loop there, and we didn't have an incrementer for LCV, our loop would loop forever. Okay, LCV would always be less than the limit. Okay, so you've got to make sure somewhere you put the LCV equals LCV plus 1. So LCV is just shortcut for, or shorthand for loop control variable. It's not a name that you'll probably use in your programming. You'll probably end up using count or whatever, something a little bit more meaningful. So a loop that never ends, so where whatever this condition is, and there could be many conditions, not just one, but there's just one here. So a loop that never ends, that condition's never met, is one that's called an infinite loop. And that could be an unintentional error. You might have left out the LCV equals LCV plus 1, or it could be a mistake. So do not write intentionally. Okay, so although we saw in a tute that even if you write a loop control, so if you want an infinite loop, you could do it several ways. Just take out the loop control variable plus 1, and that would make it an infinite loop. There's an even easier way. Just don't have a condition at all, or while 1 equals 1. Sorry, equals 1. Okay, so that would be an infinite loop as well. Yeah, so somewhere the limit is never reached, or the limit is never false, whatever the limiting condition is. 1 is always equal to 1, while this universe exists anyway, as far as we can tell. Okay, so here's an example of an infinite loop. Another one. So is 4 greater than 2? True, output hello. Is 4 greater than true? Yes, output hello. So it just keeps going forever. So in Java, you'd write that like that. While 4 is greater than 2, or while 1 is equal to 1, system out print line hello, or whatever. So we looked at those in the tute, and we saw that even if you had an infinite loop like that, okay, you can still break out of it if LCV, I've got my caps lock on, LCV is greater than or equal to the limit. Anyone that was in the tute, can you remember what we wrote here to exit out of a loop? There was a special command. Break, that's right, break, the break command. Okay, so you can always break out that way as well, and that just means leave the loop. So it comes down here to the next, or the switch structure, or okay, so it comes down to this code here, and whatever's after that just gets executed from then on. So the loop exits. Okay, so even if you do write an infinite loop, you can break out of them just with the break statement. Suspect an infinite loop when okay, it says here do not write them intentionally, but there are lots of good cases where you do. Yeah, Wayne, that's right. Break. I've just seen Wayne's comment. There are lots of cases where you do want an infinite loop. For example, you don't know how long you want to loop. For example, if you were playing Counter-Strike or Fortnite or whatever your favorite game is, you might have an infinite loop there, and it would be looping until maybe you've played for an hour. You might have a limit on your game where you're playing for an hour limit, or while the game is still in progress, while you're still alive, or while other players are still alive, or until you press the escape key and press the Q for the menu item or whatever. So you might use infinite loops, even though that question says that statement says don't write them intentionally, but sometimes you do use them. So it doesn't mean they're bad. So suspect an infinite loop when the same output is displayed repeatedly. Maybe it's just scrolling up the screen or whatever. The screen remains idle for an extended period of time when your program looks like it's locked up and nothing seems to be happening. To exit it in an infinite loop, if you're running a Java program, you can go Control-C or Control-Break. So you can exit out of them just with command line as well. Okay, so you've got an infinite loop there, Control-C or Control-Break. That will terminate the loop in a console app. If you're running a GUI app, you might need to go into Task Manager and kill your application in there. Depends on what you're doing. Here's a loop, an example. Loop count is equal to 1. While loop count is less than 3, print out hello to the screen. Loop count equals loop count plus 1. And then we keep looping while loop count is less than 3. In a flowchart, loop control equals loop count equals 1. Is loop count less than 3? If that's true, output a low, add 1 onto loop count, and go again. Loop count is less than 3, yes, keep going, until finally it's not, and we can come down here to whatever the false is. So the code under here, which is a code after that curly brace, whatever that code there is. Prevent the while loop from executing infinitely. The name loop control variable is initialized to a starting value. The loop control variable is tested in the while statement. If the test expression is true, the body of the while statement takes action and it alters the value of the loop control variable. And the test of the while statement must eventually evaluate to false. So if you don't want an infinite loop, that's how you get around it. You initialize the loop control variable, you evaluate it at the start of the loop there in a condition, and then you increment it or change it during the loop. Not really a surprise. That's how you avoid infinite loops. It's sort of not really a shock, is it? You initialize it, you evaluate it, and you change it during the loop. So what would happen if we had loop count equals loop count minus 1 in here? What would happen? So you've got to think back before someone answers. Just think back to the space integers occupy ints in Java. They're minus 2 billion to positive 2 billion or something like that. Okay, so they're big numbers. So if you keep adding 1 onto an int, eventually it will loop around and become negative, and then start from here again and work its way through the integer space again until it gets to plus 2 billion, whatever it is, and then come back and loop around again. If you take minus 1, if you take 1 off an integer, it will go negative until it gets to minus 2 billion, and then come back and be positive again, and then go back through the integer space, all the positive numbers, 0, all the negative numbers, and then keep looping back around again. Okay, so if we said loop count equals loop count minus 1, what would happen? It's not quite an infinite loop, because eventually, so clients guess an infinite loop. It's not quite, it's a long loop, but eventually loop count will be minus 2 billion, whatever it is, and it will wrap around to be positive. That's right, mine's got it there. So it will loop around until it becomes that minus 2 billion, then becomes positive, and then that while loop condition there will be satisfied, or won't be satisfied. Loop count won't be less than 3, because it'll be a value of positive 2 billion and something. Okay, so then the loop will exit. So we'll have hello printed on the screen approximately 2.2 billion times, or whatever it is, and then eventually the loop will exit. So be scrolling up the screen for a while. Okay, so that's a common error too, when people maybe this is the wrong way around, or maybe people are incrementing instead of decrementing or whatever, and the loop isn't looping as many times as you thought. So that's a common error as well for people to make when they're first starting with loops. So we've just done that one. Failing to alter the loop control variable within the body of the loop. So how many lines of code are included with this loop? So with the while loop there, and how many lines of code are in the body? Anybody got a guess on that one? Exactly right. So Wayne's got it right. So there's no curly braces there. So Okay, so here we got curly braces. If we took those curly braces out, okay, this is where the loop ends, at that semicolon. Okay, so this isn't part of the loop. Okay, that's where the loop. That's the whole extent of the loop, is from the while loop conditional statement and until that first semicolon. Okay, so this will never run. So LCV will always be less than the limit, and we'll just see the value 1, the initial value, that'll just be repeated on screen all the time forever until someone presses Control C or whatever. Okay, so just because we've indented it doesn't mean it's part of the loop. And what about this one? How many lines of code are in this if statement or this while loop? How many lines of code?
Only the while statement itself.
That's right. That's exactly right. So only the while statement itself. So none of this code here is part of the loop at all. The indentation means nothing. This is where the loop ends. So it ends at that semicolon. So how many times would that loop would that loop iterate? How many times? Once. No, it would go infinitely, because LCV is always less than the limit. So we'll just keep looping infinitely. Just running this bit of code here, which is nothing. So just keep looping and looping and looping, because LCV would always be less than the limit. It's never changing. Okay, so that's an infinite loop. And this code is not part of the loop. So you've got to watch your semicolons with loops, and watch your curly braces, watch your semicolons, and also make sure that whatever this condition is, here we've got a nice counter, but it could be while something is still true, like while the user input is still valid, or while the user still wants to enter data or something like that. So it might not be just a simple counter, but whatever this condition is here, make sure that eventually something in here can make that condition true or false so that the loop connects it. Okay. Okay, so Jared's asked the question, do infinite loops cause memory issues if you don't catch a mistake that keeps looping? They wouldn't if it's just code like this. This is an infinite loop. So this is an infinite loop as well. Okay, so this one's an infinite loop. We're not creating anything in the loop. We're just scrolling. We're just printing data out to the screen. And here we're not creating anything. Okay. But imagine we had a loop where, and we haven't done enough Java yet, but imagine we had a loop where, okay, I'll grab that earlier infinite loop. This is an easy one. So that's an infinite loop as well. There's many ways you can do it. But imagine in here we were reading a file, creating a bitmap image, or doing something dealt with a lot of data, creating or we haven't done arrays yet, so don't worry about this. It's just a data structure in memory, creating a bitmap, and we're just adding, I won't say array, I'll just say data structure. A data structure. So if we're processing data in an infinite loop and we're adding it into something in memory, then we could definitely run out of memory, and we can run out really quickly. So eventually your program could easily crash, and you'll probably see something like a heap limit reached, or an error like that. So you'll see your program crash, and in the console window, Java will tell you that there's some sort of heap error. You've run out of heap memory or something like that. And that's a sure sign that you've probably got something running in an infinite loop and you're adding too much into an array or a data structure. We haven't done enough Java yet to do this, but we'll have soon. Okay. So that can cause program crashes if you're doing stuff like that. Okay, but for what we've done so far, it'll just loop forever. And here's the flowchart to go along with that one. So loop count equals 1. Is loop count less than 3? True. Output a low. Come back and loop again. Is loop count less than 3? Output a low. Yep. Loop again. So just keep looping forever. Nothing's changing a loop control variable. So the loop control variable is a variable that is altered and stored with a new value. For example, loop count is loop count plus 1. That's when we're going incrementing forwards through values. We could be going backwards as well. Loop count equals loop count minus 1 and be checking while LCV is greater than a certain value if we're going down towards a certain value. We could be multiplying by 5 or dividing by 10 or whatever makes sense to your program. Here it's just counting, so it's a counter controlled loop, but it need not be plus. It could be anything you like. So if for example, if you want to step through by tens, so you could count by tens if you wanted to, or if you're doing something where you're multiplying by 4.51 for some reason. And you wanted to keep looping while LCV was less than whatever limit is, so you can do that sort of stuff as well. It's not always just plus 1 or minus 1. Okay, you can do whatever you like inside the loop. So an empty loop. So whatever the loop control variable is, ideally it should be altered inside the loop somewhere. Somehow, otherwise you loop a loop forever. Okay. So an empty loop or an empty body is a body with no statements, and it's usually caused by misplaced semicolons. So for example, there we've got an empty loop. Empty body, and it's an infinite loop. Okay, because of that semicolon there. So creating a loop with an empty body. So we've got a semicolon there, and here's what the flowchart looks like. Loop count equals 1. Is loop count less than 3? True. 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 And it will go forever. Okay, so this code down here will never run. It's not part of the loop. Okay, the loop ends there at that semicolon. Okay, so you've got to really watch your semicolons. Any questions so far on the while loops or the counter control loops? Any questions? No? Okay, everyone's happy. Thank you. Thank you, Pointer Pete. So incrementing the value. Here we're just adding 1 to the value. Decrementing the value is when you're subtracting 1 or subtracting something from the value. Usually it's 1, but it can be anything. The clearest and best method is to start the loop control variable at 0 or 1. That's easy. And then increment by 1 each time through the loop, and then stop when you reach a limit. For example, if you want to add up the numbers between 1 and 100, int total is equal to 0, int num is equal to 1, while num is less than or equal to 100. Total equals total plus num. So that little loop there will add up the numbers from 1 to 100. Okay, so it's start at 1, and then we've got to add 1 to num, of course. Num equals num plus 1. Don't forget that part. That's the key part. Otherwise, we're just going to add 1 onto it over and over again forever. So don't forget your incrementer. So we're adding the value of num onto total, and then we're incrementing the value of num. Okay, so this loop will keep going while num is less than or equal to 100. So it's pretty clear. We could also do it the other way as well. We could do it by counting down. So I'll do this. Num equals 100, while num1 is greater than or equal to 0, or greater than 0. So now we're counting down. We're starting at 100. Total equals total plus num. So total equals, I'll initialize it again just in case. So we created them up here, so I'm not creating them again. Created the integers up here. Okay, so num equals 0, or num equals 100 to start with. Total equals total plus 100. Num equals num minus 1. So now num's 99. Total equals total plus 99. Now num equals 98, and we'll keep looping while number's greater than 0. So that does it in reverse. That's probably not quite as clear, is it? It's not quite as clear as that first one. That first one's a bit better for us to understand, probably. Counting up's a lot more common, something we do commonly than counting down, maybe. So that's sort of the clearest and best method, usually. While loop count's greater than 1, print a load, loop count is loop count minus 1. So here we're decrementing. That's fine as well. So how many times will that loop exit, or how many times will that loop iterate? So you can work out how many times will hello? Yes, hello will appear on the screen twice. That's right, Klein. Yep. Yep. So we're starting at 3, and we're taking 1 off. So hello, and then loop counts 2. Hello, and loop counts 1, which is not greater than 1. So the loop will exit. So we'll get hello on screen twice. Any questions so far? Anyone got any issues? Not sure of anything? So up to now, we've just been doing counter control loops, but they need not be. For example, and okay, so here I've got a loop that's controlled by a Boolean. Okay, so while more input is true, I initialize it to true to start off with. While more input is true, we're getting input from somewhere, the user or the file, a file or a database or something. And if the data from the user is, or data from wherever is got a length of 0, then we can say more input is false. So we're using that to exit our loop. So when we come back up here, more input's no longer true, so our loop will exit. Okay. You can also do many conditions inside the loops, inside inside a loop, for example. I'll get a positive one. That's a bit clearer. It's got everything defined as well. While numbers is greater than 0 and total is less than 20. So here we've got two conditions. So while numbers greater than 0 and the total is greater than 20 or less than 20, we'll keep looping. So you can use ands and ors in here, and you can have as many conditions as you like. Whatever the condition is, and whatever the condition is, today's a Tuesday, or whatever. So you can have as many conditions as you like for as long as you like. Okay, so. And that won't go till 1 then, that will stop much earlier. Greater than 20, less than 20, total's less than 20. Less than 200, that might be a better limit for that loop. So we'll get something going through a couple of times. Okay, and you can use OR as double vertical bars instead of ANDs. You can, if you've got ANDs and ORs mixed together. So a question there from Jared. You can use ORs and ANDs in whiles, but not in ifs. You can use ANDs and ORs in whiles, in if statements as well. If age is equal to 10 or 30, or postcode equals 2000 or greater than equal to 2000. And we looked at char-out and the toots. Surname, won't do a char-out, dot equals Lee equals true. So there we've got ands and ors mixed together. Yeah. And I've put extra brackets in. So these innermost brackets here, Java doesn't need. I'll show you without. I'll show you without the innermost brackets. Okay, so we've got brackets around this part. So this part's going to be evaluated first, and then the next innermost brackets, which is the only other brackets remaining. Okay, so you don't have to put brackets around those in Java, although it looks really strange to me. I've got to put brackets around everything. So brackets there, and then brackets around that whole lot, and then the outer brackets, which go around that, and then there's opening bracket, closing bracket for that one. So that's what that looks right to me. That doesn't look right to me. But anyway, if that looks fine to you, you can use that way if you like. Saves you a couple of brackets. Okay, and we can do the same thing in a while loop. Okay, so the point of that is that it eventually evaluates to a true or a false. So does that one, they're both the same. And so does this, it eventually evaluates to a true or false. So the loop is going to end when that evaluates to a false. So while something's true, it keeps looping, and until we get to it. So an indefinite loop is a loop that's controlled by user input. The user might want to keep entering data until they've entered their stack of reports they need to process or whatever, or they might be entering data until they've entered enough data that they feel they've got enough. Or it could be data, it could be loops controlled any number of times. You're reading data from a file and you're not sure how many records are in the file, all that sort of stuff. So indefinite loops. Okay. If you're getting user input, you really need to validate it. So, or if you're reading from a file or a database, you might want to check the data as well to make sure it's valid. So you've got to ensure that the value falls within a specified range. And you can use indefinite loops to validate input data because you're not sure how many times you're going to loop. You want to keep looping until you get something that's valid. So if you use incorrect data, the loop repeats. let's do a shorter example first before we go into that. Okay, so let's say I'm prompting the user to enter a postcode. And I want them to enter a postcode for Victoria. So while postcode is less than 3,000 and postcode or postcode is greater than 3999. Okay, so Victoria's got postcodes starting with 3,000. So we could probably use it for an input. System.out.println, enter postcode, or enter Vic postcode for Victoria. Postcode equals, assume we've got a keyboard scanner object, kb.nextInt, just like we've done in the tutes many times. Get the next postcode from the user, they'll type something in, and this loop will keep looping while postcode's less than 3,000 or postcode's greater than 3999. Okay, so we're going to keep looping until they enter something that's a valid Victorian postcode. Okay, and then say they've got more input data to enter. So they've got to enter their age. Let's put some comments in. Postcode. Age. And the age for this system, the person must be 18 or over. Okay, so let's do a loop for that. Let's copy it. So int age is equal to 0, while age is less than 18. Enter age. Oh dear. Enter age. Okay, so, and it's age. Okay, so set age to 0 while age is less than 18. Ask the user to enter the age and get it from the keyboard. Age equals keyboard.nextInt. Okay, and this will keep looping while age is less than 18. So if they enter 17, it'll keep looping. When they enter 18, that's fine. Age 18 is not less than 18, so the loop will exit. And we'll continue down here. Right, we're coming on to that, Wayne. A very good point. Wayne's just asked about error messages. So this loop here isn't all that helpful because what if the user enters something that's wrong? Okay, we're not telling the user there's an error. And also, we're not telling the user, well, we told them to enter a Vic postcode, so that's not too bad. So if they enter something wrong, and it's just that same condition. So if postcode's less than 3,000 or it's greater than 399, system.out.println, error, not a Vic postcode. Okay. And ideally, we should be telling the user what a Vic postcode is. So just in case they don't know, they might not know, you know, we could be dealing with, we might be dealing with Victoria, we might be dealing with a little country town, you know, getting people from a country town. And it might be hard for everybody to know what that postcode might be all the time for every country town. So Victoria's pretty easy. Okay, so we're telling the user now when they've entered something invalid. Now there is a problem with this code, and we're going to streamline it further. We've got that same condition repeated twice. Okay, is there a better way? And there is. Okay, so let's come down here and also talk about age. If age is less than 18, system.out.println, age must be 18 or over. They're getting an error message down here as well. So there's also another issue with this code as well, not just that conditional statement's repeated, but the magic numbers, 3000, 399, are repeated everywhere. Okay, they're repeated 6 times just in this little piece of code. Okay, so if you've got magic numbers like that, threshold values, special constants, special values, minimum values, maximum values, all that sort of stuff, always make them constants. So I would recommend changing this code. And also we'll rewrite the code without having that duplicated. Everywhere. Okay, so we're going to fix that. So I'm declaring 2 constants, vic min postcode and vic max postcode. Okay. I'm just going to use those in our code now. So wherever 3000 is, I'm going to use the min. And it gets a bit messy when you're changing error message or strings, because you've got to close the string, do a plus, paste in the value, do a plus, open the string, and then delete the value. Okay, makes your code a little bit nastier, doesn't it? It's not quite as neat as 3000 to 399. You've got all these pluses and stuff going on in the middle, but at least you're not repeating the same value many places. Okay, let's do the same for max. So replace max, max, and now this one, I'll put it down on the next line so it's easy for us to see. Okay, but you end the string, do a plus, paste the value, do a plus, start the string again, and delete the value. Okay, so I've just concatenated the value one in there with ending the string on each side, and then plus to add the value in, and then continue the string onwards again. Okay, so this is much better code. We've at least got rid of the duplication, 3000 and 399 on everywhere. So we've improved one thing. We've still got the conditional repeater though, so maybe we can do something better there. And for what we've done so far, for the code we've done so far, we'll do it this way. Boolean data valid is equals false. So we're assuming the data is not valid. Data valid is false. Okay. While data valid is false, keep looping. So we're setting it to false. Okay, and then down here, we could put an else. Data valid is equal to true. So we set data valid to false, and then while data valid is equal to false, we keep looping. And then if the value is out of range, we display an error. Otherwise, everything's all good, and we say data valid is equal to true. So that will exit our loop. Okay, that means we don't have this repeated in 2 places. We just got it once. Okay. So we do the same down here if we wanted to. We could clean up this code. Final int min age is equal to 18. And then choose min age here, min age there, and end the quote, end the string plus the constant plus start the string and delete the value. and but we still got that condition repeated multiple times. So we could do the same trick as above as well. So data valid equals false. I've already declared it, so I'm not going to declare it again. I'm just saying data valid is equal to false because it's already been declared up above. And while data valid is equal to false, and down here we could do an else. Data valid's true. Okay, so at least we only ever got that condition once. Not really much of a savings, but at least we're following the same pattern as we had above. Setting data valid to false, keep looping while data is not valid, and then when data is valid, set it to true. Okay, so this is much nicer code because we don't have repeated values everywhere. We don't have the same conditional statement everywhere. It's not too bad when it's something like just simple like that, but when you got postcodes, you know, that could easily balloon out to have exceptions in it. You know, or the postcode is 4317. That might be part of Victoria for some reason. You know, or postcode equals this, or postcode equals. You know, I think there's Victorian postcodes which are only 3 digits. Okay, so if you're going to put all the exceptions in and then repeat all those conditionals here as well, that's going to be hideous, isn't it? So much better to have that if statement just once. Okay, because it could be not just something simple, less than and greater than. There could be a whole bunch of exceptions. Or postcode equals whatever, or postcode equals 3,301, or postcode equals 300, or postcode equals 399. There could be a whole lot of examples, exceptions. Okay, any questions on our little data input examples there we've been looking at? So I've got some code that was quite nasty with values repeated everywhere and the same conditional statements. The code that might look quite as nice when you first look at it, but at least it doesn't have the same code repeated in many places or the same values all over the place. It's just with declared constants and use those. So this is much better code, much better. And same down here, even something simple like age, we had the same issues as above, and we've solved those here. Again, the code's not quite as nice because we've got this sort of thing going on, but at least we're not repeating the same value all over the place or the same conditional structure. We're just checking age once there. Any questions on that? Everyone okay? Okay, let's go and have a look at our next slide. Okay, so we're prompting the user to enter an initial balance and next double. Interestingly enough, we're not validating that data. We're assuming we're getting something that's valid. Okay, so if this is a real bank application, we would be validating that data like crazy. But anyway, enter an initial balance. Do you want to see next year's balance? Enter 1 for yes, or any other number for no. So for some reason, user can enter 1 for yes and get the response from user. Response equals next int from the keyboard. While response is equal to 1, the balance equals balance plus the balance times the interest rate. So the interest rate is 3% or 3.03. So we're multiplying the balance by 0.03 and adding it onto the balance. Okay, so in other words, we're calculating next year's interest and adding it onto the balance. Then we're telling the user after year, whatever the year count is, it starts at 1. So after year 1 at that interest rate, 0.03, the balance is, and there's your new balance coming out to the screen. So it's a new value of balance that's being displayed. Then add 1 onto the year and say, do you want to see the balance at the end of another year? And if they enter 1 for yes, then we keep looping. Okay, response equals keyboard next int. So if they enter 1 again, we keep looping. Otherwise, if they enter anything but 1, our loop exits, and whatever the code is here would run, but there's nothing. So that's the end of our method, and there's nothing else in our class, and that's the end of our class. If this code was running and they entered anything but 1, it would just come down here and end the program. Okay, so there's a little bit of validation going on there. We're just checking whether the response is equal to 1. We're not doing any validation on balance. So validating data is all to do with data falls within a specified range or an allowed range. Usually when you've got data values like customer name and customer balance and credit ratings and credit card numbers and email addresses, all of those bits of data have got rules to go along with it. Okay, and it's all, if you're getting that data from the user, you've got to make sure you validate it. If you're getting that data from file and the file's not a trusted source, then you've got to validate that data. If you're getting the data from a database and the database isn't part of your company's data and it's not a trusted source, you've got to validate that data. Okay, because the last thing you want to do is bring in a whole lot of data without validating it and putting it in your pool of lovely clean data and having it polluted. Then you're not sure what's right and what's wrong. Okay, so you've got to make sure nothing gets stored on your systems unless it's valid. That's all to do with validating data. Okay, so there's various ways to validate a data. You can do a priming read, where input is retrieved before the loop is entered. And within a loop, the last statement retrieves the next input value and checks the value before the next entrance of the loop or the next iteration of the loop. So a priming read, and we saw an example of that in the prior slide. So we prompt the user, do they want to continue? And if they enter 1 for yes, we continue. So that was a priming read. Before we've entered the loop, we found out whether they want to continue or not. And then down here at the end, we check again, do you want to continue? And we keep looping while response is equal to 1. Okay, so that's called a priming read. We do a check of the data before entering the loop. It's a bit nasty because we've got 1, 2, 3, 4 lines of code here and the same 4 lines of code here. Okay, it says next year's balance to another year. Big deal, that's not really a change, is it? We could just as equally use that prompt down here. Do you want to see next year's balance? And then go forward another year and then go forward another year. So really 4 duplicate lines of code here and it's not really achieving much. So we could restructure our loops to do that. So we're not doing a priming read. And we'll look at some strategies for that sort of thing coming up. Here's another example of a priming read. Please enter a digit no higher than the limit. The limit is 3. User entry equals keyboard or input.nextInt. So input's our scanner object. Input.nextInt. While user entry is greater than the limit, the number you entered was too high. Please enter an integer no higher than the limit. User entry equals input.nextInt, and we're looping again. Okay, so what's the advantage of this code? Well, it's pretty easy to write, I guess. And the disadvantage, of course, is you've got repeated code everywhere. These last 2 lines are the same as those 2 lines. So you've got repeated code all over the place, so there is a disadvantage as well. Could we solve that using the strategy we thought of over here? Okay, so let's see if we can make that code better by using the strategy we used over here where we had a Boolean, and I'll assume it's a self-contained example, so I'll redeclare data valid again. Boolean data valid, and let's see if we can reproduce this part of the code here, but without having these 2 lines repeated. Out.println, enter value no higher than, no higher input, user entry equals input, which is our scanner object, next int, and if user entry, so we'll keep looping while user entry is greater than limit. Okay, so if user entry is less than equal to limit, say data valid is equal to true, else system.out.println, and display the error message. Okay, so here we've achieved the same thing as that code over here, but we haven't repeated those 2 lines of code everywhere. Well, not everywhere, but in 2 places. We've only got them once. Okay. So this doesn't do a priming read. There's no read before the loop. We assume data is not valid, and while data is not valid, we keep looping, enter a value, get the input. If the user input's valid, we set a data valid to true. Otherwise, we display an error and keep looping. Okay, so that's a nice sort of structure for validating your data. If you had more inputs, you set data valid to true, and then while, and then do all your checking on those inputs as well. So you're not letting the user go forward until they've entered something that's valid. Okay. And if you had another input to check, you set data valid to false again, and while data valid is false, keep looping. Okay, so just follow that structure, and you can't really go wrong. Just keeping the user there until they enter something valid. So priming read, meh, not really nice code. Here it's only 2 lines of code that's repeated, but it's in that prior example it was 4 lines. So yeah, not really a fan, especially when you can avoid it so easily just by decreting a Boolean and controlling things properly. Okay, that's it for while loops now. Let's talk about accumulators or accumulating. And that's when you're increasing or whatever a value by some amount, increasing or decreasing, really, decumulating. Java provides shortcuts. So plus equals is the same as saying count equal to count plus 10. You can use a shorthand, count plus equals 10. Okay, so that's the same as saying count equals count plus 10. It's just a shorthand. You can do the same for whatever. Count equals count times 120. You can do the shorthand, count, multiply equals 120. They both mean the same thing. Okay, so these are all little shorthands you can do. So you got the minus, the multiply, the divide, and the modulo. Okay, so instead of saying count is equal to count or count percent to count percent equals 2. That might come in handy. It's a strange thing to do, but things like that are probably more common when you're doing things like that. It doesn't have to be just a single value either. It could be count equals count times 120 plus 15 divided by factor minus 22 plus value. Okay, so those all work out the same as well. That would worry me though. Yeah, I would much rather write that one like that, and I would much rather put my brackets in. If I was writing that code, this one would be much better. Put your brackets in to force the evaluations in the order you want. And then it's just adds and minuses, so Java just works left to right. But if you want to do if you want to just put it in to make it super clear as well, you can do that as well. Okay. Okay, so there's all these shorthand operators there. You can use them if you want. I certainly use that one a lot because it's such a common operation. But, okay, now we come on to the increment and decrement operators. So adding 1 is such a common operation that there's a shortcut for it. So the little plus plus operator. Okay, so count equals count plus 1, count plus equals 1, and count plus plus. And also are all 100% identical. They all have the value, the effect of adding 1 to count. Okay, so, and also you can do minus 1, because minus 1 is such a common operation. Count equals count minus 1, minus equals minus minus, and minus minus count. They're all identical, and these are all identical. And you'll see this little comment here. There's no difference between the operators, the plus plus or the plus plus at the end. So the plus plus here means a prefix or a pre-increment. And over there, it's after the value, so it's a post or a postfix or a post-increment. Okay, so there's no difference between those operators unless other operations are in the same expression. Okay, so let's look at some examples. Value equals 24, plus plus value, so value is now 25. Value equals 24, value plus plus, so now value is 25. Value equals 24, value equals value plus 1, value is 25. Value is 24, value plus equals 1, so value is 25. So no tricks there, it's just as you'd expect. Plus plus, plus plus, plus 1, plus equals 1, all identical results. The difference comes when you've got other operators involved. That's when you've got to be real careful. So when you got the plus plus or the minus minus on the left of the variable name, it's a prefix or a pre-increment or a pre-decrement. And when you got the plus plus on the right hand side of the variable name, it's a postfix or a post-increment or a post-decrement. It's a postfix operator or a post-increment or a post-decrement. Pre-decrement, prefix, or pre-decrement, prefix decrement. Prefix decrement is what I probably call it. Postfix, post-decrement, pre-decrement. Yeah. It's a post-increment. It's a pre-increment or a prefix. Something like that. Pre-decrement. Okay, so you might wonder, why is he being so finicky about these two? That's because there's a trick to them. When they're on their own like that, that's all that's in the line of code, they're fine. But when you put them in amongst other things, things get strange real quick. So here's another example. And unfortunately, it's not going to help us understand what I was just talking about. But number equals 17. Before incrementing, my number is my number. Answer equals plus plus my number. After prefix increment, my number is my number. So we'd expect to see 18 there because we've added 1 to it. And the answer is, okay, so this does look at it. So we're printing it. Set number back to 17. Before incrementing my number is my number. Answer equals my number plus plus. And after postfix increment, my number is not my number, and the answer is whatever. Not really a good example, that one. Let's have a look at this instead. So what value has value got now? Not a trick question. It's not a trick question. So, yep, so it's got a value of 8. That's it, Wayne. Thanks. Let's do something slightly different. Let's use our operators. What value has count got now? Or what value has value got now? So it's still got a value of 8, but what's count's value now? Count is now 4, isn't it? So value is 8. Count is 3. So at the end of that line of code, value is 8 and count is 4 because we've added 1 onto it. And you might think, hang on, you've added a value onto it. Why didn't that also affect the value of value? Why shouldn't value be 9? And the reason is that this is a post-increment. Post-increment means the current value for count is used in calculation, and then the value is incremented by 1. Okay. If you use brackets, would that correct itself? No. Okay. It's all to do with whether which value is used as the operand is encountered. So count plus plus means use the current value for count. In this current context, use the current value of count, which is 3, add it onto 5, which is 8, and then after we've used that value of count, increment it by 1. So count has changed. Okay, so the value is still 8 and count is 4. Okay, after that line of code's executed. I'll just reset them every time, just so we're starting with the same counting values, starting values. What about if we do it the other way? So we've got a pre-increment. Oops. Hold on. I've got the wrong one. So here we've got a pre-increment or a prefix operator. So what value would value have? 9 and 4. Nice. Okay, so the prefix means update the value of this operator now, or this operand now. Okay, so update the value of count. So count's now 4. 5 plus 4 is 9. And the value of count is 4. Okay, so these guys here are identical as long as there's nothing else on the line of code. Okay, if you're using them in calculations, count plus plus is a lot different to plus plus count. Okay, so you've got to be very careful. 9 and 8. Okay, just by moving the plus plus to the start, it becomes a pre-increment. So the current value of count is incremented and used now. When it's a post-increment, the current value of count is used in whatever calculation is going on, and then the value of count behind the scenes has changed. So count becomes 4, but here in this part, the value of 3 is used. And it doesn't matter if you put brackets around it, it doesn't matter at all. It's the same rule still applies. Okay, let's get even nastier again. Who can guess what might happen here? Ooh. Okay, so what Java does? Oh, we're very close, Wayne. We're very close, very close, and very close. So what Java does, and you can't possibly know because you haven't done enough Java yet, but this means use the current value of count. So the value of 3 is used plus the current value of value plus 5. Okay, but behind the scenes here, the value of count is incremented by 1. So the value 3 is used and then incremented. So the value of count is now 4. Okay. Okay. So now, and then the value, so the current value of count, the new current value of count is used, and then that's incremented behind the scenes. Okay. So 3 plus 5 plus 4 is 12. And the current value of count is 5. Okay, so when you start doing this sort of stuff, you can make your code really nasty. We'll do one more and then we'll move on. Okay. So again, it's a good idea to break it down and write the values under here. So plus cannot be 4. Okay, so we're doing the increment and applying the change to the count straight away. And we've got plus 5. So count's got a value of 4, and then we're doing a pre-increment. So we're doing 5. So the new current value of count is 4. We're adding 1 to it and using it straight away. 5. So we end up with 14, and value of count is 5. Okay, so I said those things are all the same if you use them on, if that's all there is in a line of code. Okay, but if you use them on in amongst other things, you've got to be really careful. Here we've used them in amongst other things and we've got completely different answers, 12 and 14. Okay, so basically you don't want to write code like this. The short answer is do not write. Because it's hideous. And it's easy for people, even with simple expressions like these, it's so easy to make mistakes. But when you start doing stuff like this, int imagine you came across code like this. And that's not a, yeah, you monster. Exactly, you monster. There's some people, especially people that sort of work on encryption and stuff, they try and make their code as hard to understand as possible because they want to be in that job for life. So no, they just make it as hard to understand as possible because they're trying to make it as efficient as possible. And unfortunately, efficiency and complexity go hand in hand. So the harder things to understand, it's often the more efficient they are, unfortunately. We'll look at some examples of that coming up in future weeks. So yeah, so this code here, trying to decipher that when you've got multipliers and inner brackets. So where would you start there? Would you start there, or would Java start there? So nightmare, hideous. Unfortunately, if you work as a programmer, you will come across programmers every now and again that love writing code like this. And the trick is to teach them that int count -1, count +1, let's make it even easier. And then inside here, you could use those. And so on. Now, I'm not saying this code here will give you the same answer as that one now, because when does that run and when does that run? Okay, but I'm just showing you that you can use these sorts of extra variables to make your code a lot simpler. Okay, and you might have count +2 and count -2. Count -2 and so on. You might have a whole bunch of stuff declared, okay? But use those instead. Much easier to understand. Okay, so please don't be writing code like this. Even simple stuff like this is bad enough. But please not like that. Yeah. People will probably come and hunt you down if you write code like that. Anyway, the for loop. Let's go on to for loops. So for loops are counter control loops. And they're a compact version. So let's go back to an early version of a while loop we had. I'll just scroll back. Sorry for the scrolling on screen. So we had this while loop earlier. Let's now do the same thing as a for loop. For int num is equal to 1, num is less than or equal to 100, plus plus, total equals total plus num. Or we can even simplify that further using our plus equals operator. So look at that. We've got 2 lines of code. What was, well, 3 or 4 lines of code down to 2 anyway. Okay, so you'll notice there's semicolons in here. There's 3 parts to a for loop. It's like having 3 lines of code inside one statement. Okay, so 3 lines of code. Think of it that way. So there's 2 semicolons here. This is the initializer. This is run when the loop is created. Okay, so here we're declaring an integer num equals 1, and that's quite a common operation. You'll set int num equals 0, int num equals 1. That's a common thing you'll see, but you can do a whole lot of stuff in here, not just that. Okay, here we've got a condition, and this is when a loop, this is how long the loop exits or iterates, and this will keep looping while num is less than or equal to 100. Okay, again, you could have a whole bunch of stuff in here. You could have num is less than 100 and data valid equals true, and this is equal to true, and that's equal to false, and that's less than 44, and all sorts of things. But here we've got a nice simple condition, but you can have a whole bunch of conditions there joined together with ands and ors if you wanted to. So you have something really quite complicated that took many lines of code, many lines on the screen. And this is what happens at the end of the loop. So after each iteration, this code here runs, whatever it is, okay? And here it's just a simple plus plus 1. So adding 1 onto num. Okay, so that's equivalent to that. And are these 2 the same? Num equals num plus 1. Are those 2 loops the same? Yes. Okay, Wayne says yes. He's quite correct. Let's look at some other ones, just for fun. Okay, so like I said, these are like 3 separate chunks of code you can write. So this is like its own chunk of code. Okay, so when you see that, you might think, oh my God, that's going to have a different effect. But it's the same as saying num equals num plus 1. So all of those 4 there, all those 4 loops are identical. They all loop exactly the same number of times, and they all have the same result. So total will be the same value at the end. Now, do they all take the same speed to run? And this is something you can't know. Okay, but we'll come on to that later in the lecture. We'll come to some examples of that later in the lecture. One of these is actually a little bit faster, or if we modify it slightly, it's a little bit faster. But anyway, we'll come on to that later on. Okay, so there's 3 parts of the code. There's the incrementer, there's the testing condition that is evaluated before every iteration. So before every iteration of the loop is run, that's checked. And then there's the expression that runs at the end of the loop, and it's often called the iterator. Okay, but it doesn't have to be. It could be anything you like in there. It could be a whole bunch of code. You know, it could be code not even to do with that value. It could be doing all sorts of stuff. Okay, so there's three chunks of code, and the beauty is they're all optional. So how many times will this loop run? Anybody got a guess there? So there's no condition. It's an infinite loop. That's right. That's an infinite loop. That one's infinite. And also you can leave all three out if you want. And you just have, okay, so that's an infinite loop as well for colon, colon, colon. So they're both infinite loops. And also if you didn't increment that and still had the condition there, it would be an infinite. If you had, if you took both those out and just had blank semicolon, that's infinite as well, and all sorts of things. So many ways to do an infinite loop. That's the most compact version for a for loop. Infinite loop. So they're all optional. Each of those parts of the for loop are optional. You don't have to have them. But that's probably the most common thing you'll see. You'll probably see a loop like that. That's probably the most common. Okay, for val equals 1, val's less than 11, print out val equals 1, val's less 11, plus plus. So we're doing here we're doing the plus plus val, and here we're doing the plus plus val in the while loop. So those two loops are identical. Got to move on a bit. We've got a few slides to complete. I've been a little bit slow on some things, so I'll just move on pretty quickly. Other uses for the three sections of the loop. You can initialize more than one variable, so you can initialize more than one variable here. You can place commas between separate statements, so you can have multiple statements of Java code and place commas between them if you want to iterate. If you want to initialize many variables, you can place commas between the statements. Performance of more than one test using ands and ors. So you can have ands and ors in here. You can have not just a single condition, but multiple conditions, as many as you like. You can have decrementing instead, so minus minus or minus there, or minus 1 or minus 10 if you want to go through by tens. Whatever you like. So it's not just ones or plus ones. And you can also leave any of the sections empty. And but you can't have nothing in there. It's got to be at least 2 semicolons. That's the least you can have. So you can't have nothing. Okay. So 2 semicolons are still required as placeholders. Next slide. We'll move on fairly quickly. You can use the same for loop control variable in all 3 parts of a for statement, and that's quite common. That's the most common thing you'll see, something like these. The for loop variable there, and there, and there. And it will be used somewhere in a loop probably as well. That's the most common sort of loop. To pause a program, you can use a loop that's going to make your CPU churn like crazy but do nothing. That's just an infinite loop with a, or not an infinite loop, but a loop with a semicolon at the end, so it's got no body. It's also called a do nothing loop. It's just a loop that does nothing because there's no body of the loop. Or else there's a sleep method as well you can use to make the program pause for so many milliseconds. Might look at that in a tune. A do while loop. Okay, so for the last flavor of loops, we looked at while loops and for loops. Let's now look at a do while loop. So the third flavor, do while loop. That was our while loop. Let's now change it to a do while. So you move the while down here after that, put a semicolon, and put a do at the start. Okay. So the loop, there's no condition at the start. So we're going to do whatever's in the body of the loop. We're going to do it at least once. And then at the end, we'll check the condition and we'll keep looping while num is less than 100. Okay, so that's a third flavor of loop. So with the while loop, the for loop, and the do while loop. Okay, so why have these flavors of loops? Why have the 3 flavors? Well, the first 2 are really useful. Whiles and for loops are really useful, but why have the do while loop? That one there seems like it's something you might not need very often. But let's say there's something you want to do where you always want to prompt user for input. And either in the body of the loop, process input or exit. Okay, and you might remember early on we saw that prime input. Remember we talked about prime or priming input, priming read or priming input. Or we had those statements of prompting the user if they wanted to continue and enter 1 for yes, and then it was the same inside the body of the loop. we could have used the do while there to avoid that. Just like, sorry, I'm in a class. Please call back later. Thank you. Okay, so keep looping while numbers less than -100. Alrighty, so that's the do while loop. So if you always want to prompt the user for input, if you always want to enter the body of the loop and do at least one iteration, that's when you need to do while. It just saves you doing that priming read nonsense that we looked at earlier, that sort of nasty code. Okay, so if you always want to enter at least a loop at least once, then a do while loop's the answer. Okay, so it's also called a post-test loop because you do the test after the loop. You iterate at least once. So post-test loop checks the value of the loop control variable or the conditions, whatever they may be, at the bottom of the loop after one repetition has occurred and after every repetition from then on. So whatever's in the body of the loop, it does it at least once, and you are never required to use this type of loop if you don't want to. So everything, like I said earlier, everything you do with a for loop, a while loop, and a do while loop, everything you can do with the for loop, you can do with those two. Everything you can do with a while loop, you can do with the other two, and everything you can do with a do while loop, you can do with a for loop and a while loop. So you don't need all three loops, but in some cases, a do while loop can make your code a bit cleaner, a bit less repetition, a bit less checking, a bit, you know, one less if statement maybe. But in other cases, maybe a while loop or a for loop's better. Okay, so there can be cases where a do while loop is brilliant and it can save you a little bit of code. It says you're never required to use this type of loop because some people find them a little bit confusing, but really you need all three types of loops. Sometimes a particular one's better in some conditions or some cases. And always use curly braces if you've got multiple statements in there. So okay, so it says always use curly braces because what if you had this? If you try to leave them out, okay, Java doesn't like it. Is this a while loop as part of that loop? Okay, so is that inside the loop like this? Or is it part of that do while structure? Okay, and that's why Java wants you to use curly braces. So you must use curly braces for do while loops, even if there's only one line of code inside the loop. Okay, so the loop body is executed and then the control variables test, whatever that might be. And if the condition is true, we keep looping. So the loop's entered at least once. As an example, they could have made this code so much cleaner, but they've done the prime read again and then they've done it again down here. So anyway, we might look at that in the tutes and clean that code up a bit, make it a bit better. You can have nested loops as well. So you can have for loops inside for loops inside for loops. You can have for loops inside while loops inside do while loops. You can mix them all together and have loops within loops within loops. Any types of loops within any other type of loop you like. As many layers as you like, there's no limit. But really, once you start getting past three levels of nesting, maybe you want to make the body inside the loop, another method or something like that. Maybe there's better ways you can structure your code. Okay, but three layers or 4 layers maybe is okay. So here we've got a nested loop. For customer equals 1, customer less than 20, add 1 to customer. Color equals 1, color is equal to 3, add 1 to color, and then output a label in those different colors. So an outer control variable, well, that's true. You do the inner control variable and keep looping here in the inner loop until finally that's false. And then you go back to the outer loop, test the control variable. If it's still true, you do all the inner loops again and then go back. Finally, the inner loop will exit and go back out, back to the outer loop. Is that still true? Do all the inner loops again. Okay, so this one here is less than equal to 20 and less than equal to 3. So this outer loop loops 20 times. And this inner loop, just on its own, considering on its own, loops 3 times. So how many times will the inner loop, or how many times will the output label method be run? So it's for every inner loop, which is 3, it's going to be run 20 times the outer loop. 60, that's right, Wayne, so it's 60 times. So this method here will be called 60 times. So this inner loop here runs 3 times just on its own, but it runs 3 times for every iteration of the outer loop. And that runs 20 times. So it's 20 times 3, 60. Make sure a loop does not include unnecessary operations or statements. Makes sense, doesn't it? Don't have redundant code in your programs. Consider the order of evaluation to short circuit. We talked about that a little bit last week with conditionals, where you put the most common things to evaluate up first. It's a little bit more efficient. Make comparisons to 0 if you can. It's a little bit faster. Employ loop fusion to combine loops. That's a big topic we'll talk about later. Do not use unnecessary statements or operations within a loop's tested expression or within a loop body. Okay, so Roger's chuckle, you wouldn't want to chuck all this extra code in there that does nothing, would you? So that's all it's saying. While x is less than a plus b, you could set sum equal to a plus b, and then while x is less than sum. Okay, so that would work if a and b don't change in here. That would be fine. If a and b do change inside the body of the loop, you would also have to say sum equals a plus b to make sure it's correct for this condition to be evaluated again. Okay. And it's saying avoid this because that calculation is going to run for every iteration of the loop. And if a and b don't change down here, you don't need to do that calculation for every iteration. That's what it's trying to say there. Short circuit evaluation is where you put the most commonly evaluated or most easy to evaluate expressions first. And we did talk about this last week in conditionals. If name dot equals Mike true, or age is greater than 30, run the body of the loop, or run the body of this statement. So imagine this if statement here was contained in the loop. We're doing it 1,000,000 times or something. This is going to check the value of Mike. And there might be code before there as well. So. Okay. We're going to check if the name string equals Mike. Haven't done equals yet, sorry, don't worry, but we're just checking if name equals Mike. And we're also checking if age is greater than 30. So we're assuming there's some data there we're checking. This is really quick to evaluate because we're comparing integers. This is relatively slow because we're comparing string values. And Java's got to check the case as well as the values of all the string characters. Okay, so we can make our loop a lot faster. Well, not a lot faster, but you know, if we're looping through millions of records, it will be milliseconds faster, at least, by evaluating that condition first. Okay. So we're checking that one first, and then we're only checking the name second. Okay. And also, let's say you're checking people's postcodes. So we'll just expand this a little bit. Or postcode equals 2000 for Sydney, middle of Sydney. Okay. Let's say most of our clients don't live in Sydney. Just for example, let's say most of our customers don't live in the centre of Sydney. Okay. So I might put brown brackets around this just to make it look right as well. Okay. So both of these are equally fast to determine, but let's say the bulk of our customers don't live in Sydney. Okay, so we should probably put this first then. So we can strip out most of the data first and then do the age. Okay, so if most of our data is not, if most of our customers aren't in Sydney, that should be double equals. Double equals. I'm just writing this code quickly because I'm watching the clock as well. We're running out of time quickly, so that's why I'm rushing. So So you can also, if you're choosing which one of these to put first, if most of your data was in Sydney, centre of Sydney, or wasn't in centre of Sydney, you could speed things up a lot by putting that first as well, perhaps. Okay. If most of your data was under 30, maybe you could put that first and only then evaluate the postcode and the name for people that are over 30. So you can also speed things up by that way as well by changing the order of these. And also that also applies here. So if these are the conditions inside the for loop, inside the conditional part, same thing applies. So use short circuit evaluation. Try and get the things that are most easy to evaluate happen first, and all the things that are easiest to rule out most of your data as well first. It's important to consider the number of evaluations that might take place within the body of a loop, especially where it's going to execute many times. So this is relatively slow to work out. These two here are super fast because it's integers. Making a comparison to 0 is faster than making a comparison to any other value, which is interesting. It's just the way the programming languages work. In assembler, comparing to 0 is faster than comparing to any other value. So Java virtual machines built on code that runs on the CPU, which is eventually converted into machine instructions, which have the same feature. To improve loop performance, compare the loop control variable to zero if you can. Rather than comparing it to 100, maybe do the loop in reverse and count down to 0. It might be faster, slightly faster. Certainly if you're doing billions and billions of records, you might save a few milliseconds. It's really small differences here we're talking about, very, very small. Okay. So here we've got a loop that's starting at 0 and looping while it's less than repeat. And we're adding 1 onto the values. So it's a nested loop, and we're looping 100,000 times, 100,000, 100,000. And it's an inner one to do nothing loop, so it's just a semicolon there. And here we're starting at repeat and looping while x is greater than or equal to 0, and we're taking 1 off. So we're doing a countdown loop here. Here we're doing a count up from 1 to repeat. Here we're counting down from repeat down to 0. 0 to repeat down to 0. Okay, and there's actually a small difference in time. Even on today's Ninja PCs, you might have a Core i7 or even better, Core i9. There is a difference in time, okay? But you've got to do a lot of iterations, like 100,000 times 100,000, okay, to find any difference at all. And the difference is small. We're talking about milliseconds difference, okay? So just by changing the way your loops work, from count up to count down, and using that minus minus and changing to plus plus, you can shave off a few milliseconds if you're processing millions or billions of records, or billions of bits of data. Okay. And here we've got some benchmarking coding. We're using local date time now. Now equals local date time dot now. So we're getting the current time. This is a very accurate timer. Start time equals now dot get nano. So we're getting the nanoseconds from start time, from the current time now. Then we get now equals local date time dot now. End time equals now dot nano. So we're getting the milliseconds as an end time. And then we can end time minus start time divided by factor. So we're dividing by a millinet to convert that to milliseconds. Okay, so end time minus start time divided by a million, and that gives you the number of milliseconds. So we're using pretty accurate timers here. And you'll see if you run this code, you'll find that there's a slight difference. Yeah. Loop fusion is a technique of combining multiple loops into one. It won't work with every situation. It's a huge topic. We're not going to even talk about any examples here. It's a big topic. We'll talk about it later in the course. The prefix increment is plus plus, so prefix or pre-increment. The postfix increment is x plus plus, or the plus plus after the variable name. So the value of x is increased and used straight away. And here the current value of x is used, and then the value is increased. Okay, just look back at our prior examples. We cover that pretty thoroughly. So there's some examples there of using plus, and you can time those as well, and see if there's a difference, and there is actually a slight difference. Okay. So that's it for this lecture. So so we'll cover all this in the tutes again. So we've got the tute coming up on Friday. Any questions before we finish up? Anyone got any questions on anything? No questions? Oh, everyone's good. Thanks, Troy. Okay, thank you, Troy. We'll do lots more of this in today's tute. I have a question that required some code. I was writing to practice, but that's for me. Hey, Jared, if you want to email me a code, I could work through it and do a short video and upload it, or else we could talk about it in Friday's class and talk about it during the video in Friday's class. So email me a code and I'll have a look at it if you like. Yeah. Okay, it's 11:57. How many people are still here? We've still got 16 people. So that's pretty good, 16 people. I think we had 16 near the start. So everyone stayed until the end. Thanks for staying. Hope everyone's staying safe. We're living in strange times. That's all I can say, strange times. So stay safe and look after each other. Look after your families and friends. Yeah. Okay, take care, everyone. Thanks for taking part, and have a good week and a weekend. Thank you. Yeah, wash your hands. That's right. Keep washing your hands. Okay, take care, everyone. Thanks for coming. See you Friday.